Below, we introduce a test of a light color mode of the Spectrum test software. As for the light color test, it is to detect an absolute spectrum of the light source and calculate and display a parameter of related optics and colorimetry. It's still the same. Before the light color test, we need to open the software, adjust its integration time in the original Spectrum interface, and click Single Test or Continuous Test. Let's adjust its integration time. Okay, that's it. After adjusting the integration time, this mode switches to light color mode. We choose to test. Then click. Then the light color test is done before the test. It cannot be tested directly. A spectral calibration needs to be performed first. Under what circumstances does spectral calibration occur? Spectrally calibrated. What about situations where spectral calibration is required? The first situation. That's when you test it with light and color mode for the first time. Then what? The second one is after you have finished calibrating. Already tested. But your device, your product, and your fiber, including your integrating sphere and other accessories, you move through. It changed position. This will require recalibration. Why perform spectral calibration? What about spectral calibration? Is not a prerequisite for the normal operation of the software. But what if no calibration is performed? It will affect the accuracy of calculating optical parameters. The reason why it is calibrated is to enable it to be tested. The test data is relatively accurate. We proceed to the following one. Also, the Spectrum is opened in the original software. After adjusting the integration time in the original Spectrum. Then after we switch to this light color mode. Just don't adjust its integration time anymore. Then we will perform an operation of spectral calibration. First we click. Then click Spectral Calibration. After clicking on Spectral Calibration, everyone can see an interface. This is an interface for spectral calibration. What about when setting the benchmark? We need to set up one of it first. Our wavelength setting must be the same as the wavelength of your spectrometer. Let's set it up. 350,950. Integration time. This integration time should be the same as your current integration time. After adjustment, the time will be the same. Our sampling times are the same as before. We need a luminous flux based on your data, color temperature, and your standards. It depends on the data of a standard light source you calibrate. So what is the color temperature and luminous flux of your standard light source? Let's set the number based on it. Then we will default to 3118 here. After setting up, let's click to set the calibration parameters. What about after success? We need to do an operation of turning off the light to call the bell and turning on the light for calibration. So first of all, what about when we calibrate? Ringing the bell. Before ringing the bell, we need to turn off the light source. To turn off the light source, remind you to make sure to ring the bell under dark conditions. That is, when your light source is turned off. After the bell is called, we turn on the light source. At this time, do another. Then now when there is light, the light source has been turned on. Then we click Calibration. It will prompt you to make sure you calibrate with the standard light source on. At this time we are setting the benchmark. The following one is to read the calibration file from the hardware, and a calibration file written to the hardware. What about this time? If we don't want to recalibrate next time. If you want to extract the calibration file directly, we can choose to write the calibration file receipt to the hardware. In this way, when we calibrate next time, you can directly open this interface. Direct. Then the next time you open it, directly clickable from the hardware. Read calibration file data. You don't need to set up anymore. Then we won't write about it here. Then after the calibration is completed, let's click on the test and take a look. This is OK and normal. Under normal circumstances there should be no problem. Of course I use a natural light here, not a standard light source. Normal if it is a standard light source. It will become an arc. What other functions are there in light color mode? It's in a project option below it. It can measure some time. Chromaticity coordinates XY. Correlated color temperature. Still have some spare value. And the luminous flux. Power. Radiation power etc. And its peak wavelength. Dominant wavelength. These are all testable. Then let's go here. If you add anything below, it will show what. Of course if you don't want a certain data, then you can remove it from here. Remove. How to operate it? Let's take a look. First click on this project option. Some will come out of here. You can also use the name of some project options to appear here, including a project we have added now. What about the left side? Is an addable item. Current items and addable items added together. It's all we can do. A software that can be tested. We want. For example, if you want this ID, then add it in. We choose to add it. So it goes to the right. Change to a currently used project. Click OK. So it will come out inside. Of course if you don't want some, such as a 15, let's remove it. Click Remove. That's OK then. There won't be any more R15 in it. A use of the project. What about the above? It is an operation method of light color mode.